Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam LTAM. Previously, I posted it in the PDF file. On May 20th, 2006, you are given that the future lifetimes t of x and t of y are independent, and each has the density f sub t of t equal to 0.1 minus 0.005 t for t between 0 and 20, and 0 otherwise. You are also given that the force of interest is 0.05 or 5%. Find a single benefit premium for a plan of insurance that pays $1 million upon the death of y at the moment of death, but only if x is still alive. And here's the solution. Let's start with noticing that TPX, the property of x being alive at time t, is the integral from t to 20 of 0.1 minus 0.005 s ds. And that's because it's the integral of a density going from t to 20. That's 1 minus the integral from 0 to t of 0.1 minus 0.005 s ds, and it's equal to 1 minus tqx, obviously. And now we continue the solution. The single benefit premium is 1 million times a bar x colon y with 1 above the y. And as you can see, it pays upon the first death if y dies first. So that's why it's x colon y, no bar above them. Pays upon the first death. It's the integral from 0 to plus infinity of million times v to the t, which is the present value of benefit, times tpx, because x is supposed to be alive, times tpy, times mu of y plus t dt. Well, tpy is y lives to that moment, then gets instantly whacked by the force mu of y plus t dt. So that's this expression, of course, is tpy times mu is the density of t of y. So this is 1 million times the integral from 0 to 20 of e to the minus 0.05 t times the integral from t to 20 of 0.1 minus 0.005 s ds, which is tpx. That's what we pointed out before. And that's equal, it's multiplied by 0.1 minus 0.005 t. That's f sub t of y, evaluated at t, dt. Okay, so that's equal to 1 million times the integral from 0 to 20 e to the minus t over 20, because 0.05 t is t over 20. Then we factor out 0.005, and we have it twice factored out, so squared, times the integral from t to 20 of 20 minus s ds times 20 minus t, because 20 times 0.005 is 0.1. And that's equal to 1 million times 0.005 squared over 2 times e to the minus 20 over 20, times the integral from 0 to 20 e to the power 20 minus t over 20 times 20 minus t cubed dt. And now we're going to do integration by substitution by taking 20u to be 20 minus t, so that minus 20 du is equal to dt, and this becomes 12 over 5 divided by e times the integral from 1 to 0 of e to the u times 20 cubed u cubed times minus 20 du. And then that of course, divided by e, because e to the negative 1 is 1 over e. And that's 12.5 times 20 to the 4th over e times the integral from 0 to 1 of u cubed e to the u du. And we just do integration by parts on this 3 times and we'll be done. Okay, so one integration by parts, w is u cubed, z is equal to e to the u. And after we do this, we end up with the expression you see there, which ends up being 12.5 times 20 to the 4th over e times e minus the integral from 0 to 1 of 3u squared e to the u du. We do integration by parts by taking w equal to 3u squared, z equal to e to the u. This leaves us with 12.5 times 20 to the 4th over e times e minus 3e plus integral from 0 to 1 of 6u e to the u du. We take w to be 6u, z equal to be e to the u, and this whole thing becomes 12.5 times 20 to the 4th over e times e minus 3e. This, my apologies, this should say 3e. I'm going to pause. So my apologies, I paused and corrected as 3e. Plus 6u e to the u evaluated from 0 to 1, which is 6e. Minus integral from 0 to 1 of 6 e to the u du. Well, that's not a hard integral to do because integral of e to the u is e to the u. So after we do all this work, we end up with 12.5 times 20 to the 4th over e times e minus 3e plus 6e minus, well, this thing ends up being just 6 e to the first minus 6 e to the 0. So after we calculate, cancel out things and so on, this ends up being 6 minus 2e. And then we calculate it's approximately 414,553.29. Please remember this is copyrighted material. It was created by me. The solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.